morning students, welcome to my class. So still now you solve many problems in algebra, trigonometry, arithmetic, geometry, right? So in those part of mathematics you solve the problem of static world. Like think about this problem. We have a circle with radius r. So here the radius is fixed. The circle is not changing. So it's the problem. Now you have the problem to find the area of the circle. So this problem is like a photo, right? We have a picture of circle and we have to find the area of the circle. But think about the real world. Is the real world like a photo? No. It's like a video or everything is changing, right? So when we actually work on the real world, many problems we get which can't solve using our previous knowledge. Here we have to have the knowledge of calculus. So think about a problem. You are on a road trip. You covered 100 kilometers in 2 hour time. So now if I ask about your speed on your trip, so you will say 100 kilometers by 2 hours, so it's 50 kilometers per hour. But think about the reality. You are not always travel on this speed. So now think about that situation. A police officer with his speed gun measuring your speed. So he is measuring your speed just a fraction of second. So you calculate the speed of your motorcycle with this time interval, right? With this time interval, 2 hours. But think about the policeman's scenario. The policemen have no data of your previous journey, right? It's just a fraction of second. He calculating, not he calculating. The machine is calculating your speed at that moment. It's just about fraction of second. So how he's calculating your speed in a fraction of second? So here the calculus, here the concept of calculus comes. The limit concept. That here the time duration is very small. Very small. It's just like a 0 second time interval, right? It's a fraction of second. So is it possible to distance travel by 0 second to calculating your speed? No, right? It's mathematics. It's break the mathematics rule, right? So what's happened when he measuring your speed? It's using limit concept. The time duration is tends to 0, not equals to 0, right? So it's a fraction of second. So the machine, the radar machine, is calculating just your your speed using the time duration tends to 0. How much distance you are covering? So let's say you are covering the distance del d, right? So del d. So okay, let's write capital D. So it's also be tends to 0, right? It will be very, very, very small, infinitely close to 0. The time duration and the distance also. So when he find your speed by del d by del t, so we will get close to 0 by 0 form, right? So here calculus comes to solve those type of problems. So we will write this expression like this. Here we write the limit tends to 0 in this way. We get 0 by 0 form. So the problem we get can't solve using our previous knowledge of algebra, right? We have to know the knowledge of calculus. So that's why I am here to teach you the concept of calculus. So let's learn how we denote a limit expression. So how we will read this expression. Let's take x tends to a f of x. This expression we will call it as limit x tends to a f of x, or limit of f of x as x approaches to a, or you can say limit of f of x as x tends to a. This is called x tends to a, x approaches to a, this type of thing. So let's jump into another problem. Let's take a function. So let's take this function, this problem. So can you find f of 2? Can you find f of 2? No, right? Why? If you use your previous knowledge of algebra, what you will write 2 minus 2 and 2 square will be 4 minus 4. It's just 0 by 0. It's break the mathematics rule, right? So, but we are getting, we are unable to find f of 2 using our previous knowledge. Also, here the denominator is x minus 2, right? X minus 2. So when we write this function, we have to write a condition x not equals to 2, right? Because if a denominator can be 0, so when we write this expression, we have to add this condition. So let's if I write this condition, so the expression will be, let's expand this x plus 2, then we will get simply, how we can write this? Because we write this condition, we know x minus 2 not equals to 0. That's why we cancel out the numerator part and the denominator part, right? So now think about the graph of this. So this is a straight line, right? Y equals to x plus 2. So let's draw the graph. So this is a graph of the straight line, y equals to x plus 2. Now here is a special condition, x can't be 2. So here at the point x equals to 2, we get a hole because we don't know, we unable to find the y at x equals to 2. So that's why we get a hole. It's called hole, a black hole in mathematics, right? So, so but how we can find let's how we can find what happening around x equals to 2. So let's take limit x tends to 2, x tends to 2. So this will be x plus 2. Okay, so we can simply put the value of 2, uh, the value 2 in place of x. We are no we are not getting any difficulty to putting the value to putting the x equals to 2 here. So we are getting f of limit value of f of x at 2 equal to 4. So what is the meaning of this? This means when we go infinitely close to 2, we will get the value of f of x equals to 4. So that means there is only one point which is undefined. But if we go infinitely close to that this point, we will get the value of f of x equals to 4, right? So now I hope the concept of limit, basic concept of limit, clear. So now the question is, the limits of the functions is always exist. Think about this. So now take a point x equals to a, right? We are saying x tends to a means x approaches to a. Now we can approach from this side, also we can approach from this side, right? So just imagine this is a wall in the point x equals to a. You are going toward the wall from this side, and you can't go beyond the wall, and also you can't reach at exactly x equals to a because of that wall. And when you are here, you will approaches from this side toward the wall. The same condition happens. Now, now think about when we analyze the function's behavior at this sublimit. There are two conditions we get: approaches from left hand side and approaches from right hand side. Right? So we denote those two limits as a limit x tends to a minus. What is the meaning of a minus? A minus means a minus means approaches from left hand side. Okay, because when we imagine the number line, this side is smaller than a, right? So that's why we denote this left hand limit as x tends to a minus. And there is a function. So and another condition we will get from when we approaches toward a from right side. So we will get two values. Now if those two values are equal, then we will say that the limit of f of x is exist at x equals to a. If those limit does not exist, those limits are not equal, then what will happen? those limits are not equal, then we will get two different values for one particular point limit. So that's why here we say the limit of f of x, the limit of f of x, the limit of f of x does not exist at x equals to a, right? So let's try some example on this concept. Think about this problem. Limit x tends to 0, let's say. Now, if we approaches x equals to 0 point from left side, so that is left hand limit. So we write this as this. So now we are now come to the number line. We are approaching from left side. So when we are approaching from left side of that particular point, x equals to 2. So we are choosing the negative numbers, right? Any point any point if we take from the left side of this point, always negative, right? So in this case, x is always less than 0, because we know x tends to means x not equals to 0, right? We are taking left hand limit, so that's why x is now less than 0. So if x less than 0, then what will be mod x equal to minus x, right? So minus x by x we will get. So now simply it's not equal to 0, right? So that's why we can cancel out x and x. So what we will get? Minus 1. Now examine the right hand limit. So what we will get? Now think about we are at the right hand side of x equals to 0. So in this case, x will be greater than 0. So x greater than 0 means mod x equals to mod x equals to x. So that's why we can put x instead of mod x. So that this will be 1, right? So what we are getting? We are getting the value of left hand limit is minus 1 and the right hand limit is plus 1. So those are not equal. That means the limit does not exist. So this does not exist. Okay, got it? So in this way, we can solve the problem. We can find a limit exists or not. Now